This question says two particles P1 and P2 start moving from point A at the same time along different straight lines. It says after t seconds, the position of P1 is given by r is equal to, and then 4 minus 1, 3 plus t times 1, 2 minus 2. And part A says find the coordinates of A. So A is the point where they start moving from. So it's going to be the initial point here, so it's going to be the point where t is equal to 0. So therefore it's just going to be this starting point here. So A is going to equal 4 minus 1, 3. Alright, then it says 2 seconds after leaving A, P1 is at the point B. And then we've got to find, first of all, the vector A to B. Alright, so there's two ways we could go about this. We could put in t as 2 and work out where B is, and then I could work out how far it is from A to B. The other thing I could do is I could recognise that when moving from A to B, we're just going to have two lots of this vector here. So A to B, let's do it both ways. So let's first of all work out where B is. So B is going to equal 4 plus 2 times 1, because t would be 2. So the A value would be 4 plus 2 times 1, and then that would be the x value. Then the y value would be minus 1 plus 2 times 2. So minus 1 plus 2 times 2. And then 3 plus 2 times minus 2. So that would give that B is equal to, so that's going to be 6. And then 3. And then minus 1. I could then say that A to B would be from A to B, so from 4 to 6 would be up 2. So A, B, from 4 to 6 would be up 2. Then from minus 1 to 3 would be up 4. And then from 3 to minus 1 would be down 4, so that would be minus 4. Like that. Now, as I said, you could also recognise that A to B would just be two lots of this vector here, because the starting point and the finishing point is just going to be an offset from where. So to get from A to B, this describes how to get from point to point, and we know that it takes 2 seconds to get there, so it would be 2 times this. So we could do 2 times 1, which is 2, 2 times 2, which is 4, and then 2 times minus 2, which is minus 4. So either way there, that would be fine. Now, next we want to work out the modulus of A to B, so that's the length of A to B. So modulus of A to B, this one here, is equal to, I'm going to write that, I'll write that here. So that's going to equal the square root of 2 squared plus 4 squared plus minus 4 squared. So just using Pythagoras' theorem to work out the length of the actual thing there, we take the 3, the x, y and the z coordinates, square them all, add them together and take the square root using Pythagoras' theorem. So then that's going to give me 2 squared is 4, 4 squared is 16, so that's 20, plus another 16, so that's root 36, which is then equal to 6. Okay, that's done that. So then it says 2 seconds after leaving A, P2 is at point C, where A to C is 304. Part C says find the cos of angle BAC. Alright, so I think what we're going to need to do here is draw a diagram. So we've got one vector here, A, and we've got point B here. And then we've also got, so that is our vector, the motion of our particle P1. So P1 is going along this vector here. So 2 seconds P1 is going along here. So this is for P1. Then we've got another particle, it says 2 seconds after leaving A, P2 is at point C. So we've got a second point also leaving A, coming down here, which is point C, and P2 is going along this way. So we're going A to B, B to C like this, and it needs us to find this angle here. So it's given us a little bit of a clue here because it's asked for the cosine of angle BAC. So again, there's a couple of ways we could do this. We could, if we wanted to, since we could work out the length of this line, work out the length of this line, work out the length of this line, and then use the cosine rule. That would be one way. Alternatively, we could use the vectors for these two and do the dot product. So I'm going to do it the second way. So what we need to, we know the vector from A to C, and we've already worked out the vector from A to B. So what I can then do is I can say that cos of theta is going to equal vector A dotted with vector B divided by the modulus of A times by the modulus of B. So that's what the regular way of working out the angle between two vectors. So in this case, we're going to need to do vector AB dotted with vector AC over the modulus of AB multiplied by the modulus of AC. So that's what we want to do here, and that's going to equal to cos theta. Now we've already worked out what AB is. It's told us what AC is. We're going to need to know the modulus of AC here. So if we go back up here, I can work out the modulus of AC is going to equal the square root of 3 squared plus 0 squared plus 4 squared. So that is going to be 5. That's a Pythagorean triple, 3, 4, 5. Okay, so therefore we should be in good shape for working this out. So cos of theta is going to equal, and then we first of all need AB. AB is 2, 4, negative 4. That's going to dot with AC, which is 3, 0, 4. And then we're going to divide that by the modulus of AB, which was 6, and then multiply by the modulus of AC, which was 5. So we can then work out what this dot product is. So when we work out the dot product of vectors, we multiply the top two numbers together and then add the second two numbers and then add the third numbers. So 2 times 3 is 6, and then plus 4 times 0 is 0, and then plus minus 4 times 4 is minus 16. And we're going to divide that by 30. So that would mean that cos of theta is going to equal minus 10 over 30, which is minus 1/3. All right. Then lastly, it says hence or otherwise find the distance between P1 and P2 2 seconds after they leave. So P1 was moving along this way, and P2 was moving along this way. So basically what it wants us to find is the distance BC. So this means find the modulus of BC. Alright, so we could do it various ways. Again, we've now got this angle here, or we've got the cosine of this angle. So we could use the cosine rule to work out this one. Or I think what I'm going to do is I'm just going to work out what the vector B to C is, since I know where point B is. Point B is here, and I can work out where point C is because I know where point A is and I know what the vector A to C is. So where is point A? Point A is at here, 4 minus 1, 3. I'm just going to write these things further down here. So this is part D. A is at 4 minus 1, 3. B is at B is at 6, 3 minus 1. B is at 6, 3 minus 1. And then we know that A to C is equal to 3, 0, 4. Alright, and we're trying to find the modulus of BC, not AC. We're trying to find the modulus of BC. So, okay, so having written these down here, I can then use A is at 4 minus 1, 3, and the vector A to C is 3, 0, 4 to work out where C is. So C is going to equal, we start with A add 4 and we go up an additional 3, so it's going to be 7. Then we start at -1 at A and we go along 0, so that's going to remain -1. And then we start at 3 and we add on additional 4, so it's going to be 7. So that means point C is at 7, -1, 7. What I then want to do is work out vector B to C. So vector B to C is how I get from point B to point C. So from 6 to 7 is up 1. From 3 to -1 is down 4. And then from -1 to 7 is up 8. So that means vector B to C is 1, -4, 8. And then finally I can work out the modulus of BC, which is what we were trying to do. So the modulus of BC is going to equal the square root of, and then 1 squared plus -4 squared plus 8 squared, which is going to be square root of 1 plus 16 plus 64, which is going to be the square root of 81, which is going to be 9. So the answer is 9. We can just write that down. P1 and P2 are 9 meters apart when T is equal to 2.